You know what? I think you'll remember. So I'll just let you come grab this. Just don't forget, okay? Because I've had people walk off with this before. All right, guys, let's go ahead and dive in. So we're continuing working with real numbers. And today we're looking if the real number is a perfect square or really whatever real number is given to you, how can you take the square root? Or we're also going to look at cubed roots. So with that said, we first need to look at this definition. This is one of those things where probably in the past you've skimmed over it. Maybe your teacher didn't even reference it. But for Algebra 2 purposes, understanding this definition is really vital for success, not only in this chapter, but in sequential chapters. So let's go ahead and let's dive in. What is the definition of an nth root? If you're like, what's an nth root? That's this piece right here. And let's go ahead and take a look at the definition. If n is any positive integer, so stop, take a look at n. Where does n show up? It's right here. So if n is any positive integer, then the principal nth root of a is defined as follows. The nth root of a equals b means that b to the nth equals a. Now, I really like to add an actual example that you've seen before to bring meaning to this. So here's an example. Let's say that we have the square root of 9 equals 3. According to the definition, this means, notice A is represented as 9, B is represented as 3. This means that 3 raised to the nth power is going to equal 9. Now, hopefully that immediately brings you maybe cause for concern or just wondering, or maybe just bringing back into memory. 3 raised to what power equals 9? 2. But wait a minute, there's nothing written in here. Have you guys been told it's by default 2? If there's nothing written there, it's like one of those invisible math things that you just have to know, and it's really important that you know it to be successful. So by default, there's a 2 there. And you can see by the meaning, this means that 3 squared gives you 9. So if you didn't know that, I would go ahead and make a little note of that. If no root shown, it is 2. Means it's a square root. Now, that's not the only important piece of information we have to focus in on. This next piece right down here. If n is even, well, let's talk about it. That example that I just gave you, was n even? Take a look at n. N is the little index. Is 2 even? Okay, so if n is even, which it is here, then you must have a being greater than or equal to 0. The fancy way of saying that is saying that a has to be positive. So that means this guy, he's representing a, which is 9, must be positive. So go ahead and write must be positive. And not only that, not only the number under the radical has to be positive, but also the answer. So take a look how the fact that b represents the answer. Here, b is represented with 3. That means that must also be positive. So let me say this in layman terms. If you have an even radical, the number under it has to be positive and the answer to it has to be positive. Let me give you a non-example. Here's something that would not work. The square root of 9, that's actually asking you the principal root of 9 is not equal to -3. I know it's not equal because by definition, that answer must be positive, and it's not. Now, that's going to be really important when we start working with variables. So just make sure to kind of keep that in mind. Speaking of variables, take a look at this language. This is going to be how the textbook looks. This will be how certain quiz or test questions look. And understanding the language is really important. This language says all variables represent any real number. We're going to come back to that when we get to example C with variables. For now, let's review. I talked to Mr. Cheney and Ms. Gregerson, who most of you had last year. They said they taught both methods of simplifying radicals. I'm happy they did because I use both methods, and it's just really good to know both of them, and you might use a mix of them. So let's start with method 1. Method 1, if we're looking at simplifying radicals using prime factors, that means take the number under the radical, so in this case 8, factor it all the way down until you can't go any further, until they're just prime numbers. So you guys tell me, what goes into 8? 4 and 2. Is that as far as I can go?
No, yes.
It's yes with the 2, but 4, oh, I see, just mixing it up. 2 and 2 is 4. But then I would strongly recommend you bring down this so you can see the prime factorization just lined up. Otherwise, it's easy to miss these. So we would rewrite the square root of 8 as its prime factorization, which is 2 times 2 times 2. Now, let's see if you guys caught the beginning. There's nothing written in that root. What is it understood to be? It's assumed to be 2. This little index, this root, will tell you how many of the same factor you need before you can take it outside of the radical. This 2 tells me I need a perfect square. I need a number times itself. Once I find 2 of the same number, a number times itself, I can then take it out as 1 to the outside of the radical. When I was a kid, my mom would give me the responsibility of like the unmatched sock bin, and I'd have to try to match the socks. And when I found a match, I'd clump it together and take it outside of the basket, the unmatched basket. This is what this reminds me of. When you find a pair, clump it together, take it out as 1. And so my answer would be 2 square root 2. Now that's using method 1. Method 2 would be, you know your perfect squares, so you're going to simplify maybe a little faster. What's the highest perfect square that goes into 8? 4. So I could just call this square root of 4 times square root of 2. And then I would simplify. What is the square root of 4? 2. So I'd have 2 root 2 as my answer. Now, before you box that, I really want to make sure you understand why that was simplified so easily, because it'll be helpful when you start looking at variables, if you like this method. The reason we simplified this so easily is because 4 is really 2 squared. And the key here is that the square root cancels out the square, and that's how we get that 2 on the outside. It's just really important that you understand that meaning because it'll be helpful when you look at variables. But our answer is still 2 root 2. All right, let's continue again. Example B. Looking at the number 98. Let's factor it down. What do you know goes into 98? What'd you say? 14 and 7. Oh, wow. I didn't look at it like that, but that's a great way to look at it. 14 and 7. Nice job, Carlton. Can 14 be factored down further? 2 and 7. So if I bring this down, if I'm using the prime factorization method, I would rewrite 98 as its prime factor, 7 times 7 times 2. What's the root again? 2. So how many of the same do I need before I can take it out? 2. And the reason I ask that is because we will look at cubed roots, which implies you need 3 of the same factor. But right now I have 2 of the same. I can take it out to the outside. And my answer is 7 root 2. It's beautiful. Now, if you wanted to go the other way, you might have even seen from the factoring tree. What's the perfect square that goes into 98? What's 7 times 7? 49. So you might have said 49 times 2, and then taken the square root of 49, which is 7, and you'd have that 7 root 2. Again, if you really like method 2, make sure you know what you're doing. 49 is really 7 squared. So the square root is undoing the square, which is true of the other method as well. But that's going to be really helpful for simplifying variables. And that is 7 root 2. Do you have a question, Charlie? Oh, sorry, question. All right, now to the variables. If I'm factoring this down, x to the 4th, how many x's would I have in my factor tree? 4. 1, 2, 3, 4. So if I'm writing this under the radical, 1, 2, 3, 4. Again, how many of the same do I need before I can take it out? 2. So I have one group. I'm going to take it to the outside. I have another group. I take it to the outside. Notice anything that you take to the outside, you multiply. So cleaning this up, what's x times x? X squared. Now, before you box it, we need to stop and think about it. X can represent any real number. What if x equals -1. Remember, from the definition, the answer can't be negative. It has to be positive. So let's see if this still works. If x was -1, what's -1 squared? 1. It's positive, right? So it fits the bill. What if x was -2? What's -2 squared? +4. So this fits the bill, and I can say, go ahead, box it. It's a positive solution, which is important. We will get to what happens if it's not. But did you have a question on that one? It could be 3, it could be 2, it could be 3, it could be any real number. I just have to make sure that when I square it, it's positive. Well, x has to be the same number because x is representing one number, but it can be anything. So if it's 3, then it's 3 times 3, which will give me 9. If it's -3, -3 times -3 gives me +9. So I still have that positive. What if the root was 3? Oh, if there were 3 x's, then we'd have 1 left inside.
Another set of x. So
like here? Oh, that's what we're going to talk about. Then you're going to need something in your answer. Great question. So you're already thinking ahead. We'll get there, okay? All right, guys, if you're a perfect squares type person, x to the 4th actually is a perfect square. You could go ahead and jump to the answer. The answer is x squared. If you're saying, how is it a perfect square? Think about what we did above. The square root is going to cancel out a square. How could I rewrite x to the 4th as something squared? Well, anything raised to a power you multiply. So x squared squared produces x to the 4th. And therefore, you can see your answer is still x squared. So if you like this method, it still works. Still great. You just have to think what's being squared to produce the value under the radical. All right, on to letter D. Letter D, if I'm using the prime factorization method, how many y's do I have to write out? 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many of the same factor do I need before I can take it out of the radical? 2. So I have 1, take it out. Another pair, take it out. Another pair, take it out. And another pair, take it out. Simplify the outside. What does the outside come out to be? Y to the 4th. Nice. What's left in the radical? Square root of y. Good. And then we want to make sure this is positive. Is any number raised to the 4th power still positive? Yes. So we're good. We can just box it and we're done. If you are a perfect squares type person, the perfect square that goes into y to the 9th evenly is actually y to the 8th. You could call this the square root of y to the 8th, or square root of y to the 8th times the square root of y to the 1st, because 8 plus 1 would give you 9. What is the square root? Miles and Logan, you guys are being kind of distracting. You guys just focus up here. This is the tapping, and you guys were just kind of throwing a water bottle and stuff. Sorry, it was distracting me, so maybe it was only me. But if you could just make sure that you're getting it, okay? So square root of y to the 8th. Does anyone know square root of y to the 8th? 4. It's y to the 4th. And if I'm thinking about how does that work, it's because y to the 4th squared is what produces y to the 8th. So I have y to the 4th square root of y. Okay, the next example is where Charlie already hit on it. We need to talk about what if x is negative. So let's go ahead. Let's try using method 1, the prime factorization. So as I draw it out, how many x's should I have? 2. How many y's should I have? 8. 1, 2, 3, 4, 5, 6, 7, 8. It's a square root, so I need 2 of the same before I can take it out of the radical. I have 2 x's. Let's take it out. And then I want to talk just about the x before I simplify the y. X represents any real number. Well, wait a minute. If it can represent any real number, I have to show that it fits this definition. If I go back up to the definition, that number on the outside, it can't be negative. So I'm going to have to do something to my answer to make sure that x is not negative. Do you guys know any math symbols we can put around something that will always make it positive? Evan?
I was gonna say
Oh, we could do that if we were an equation. If you had an equal sign, whatever you multiply one side by, you can multiply the other side by. But because this is an expression, we can't multiply it. But there are some symbols. Lily? Absolute value. Putting absolute value around the x will then make this problem work. It'll show that if x came out to be a negative number, it can't be. So make sure that you know that it's positive. Just like if I went back up here and I said the square root of 9 is the absolute value of -3, now I could say that works and it's equal. So that's important. You want to be thinking about, when do I need that absolute value? Okay, let's talk about the y's. Let's see, how many pairs do we have in 8 y's? You might already know it, 4. So we're going to have a y to the 4th out here. Or you could just circle it, circle it, circle it, circle it, but you're going to be circling 4 pairs. So our answer, if I clean it up, would be the absolute value of x, y to the 4th. And again, if you don't like that method, there is another one available to you, and that's recognizing perfect squares. X squared is a perfect square. The square cancels out the square, so I have x on the outside. Y to the 8th is a perfect square. It's y to the 4th times y to the 4th. So I can just take out that y to the 4th. The only other thing I need to keep in mind is absolute value is still important. Why don't I need absolute value around y to the 4th? Because it's even, and any number raised to an even power will maintain, it will be positive. Okay, but I need those absolute value marks, and then I'm set. Logan? Absolute value, yeah. It's on the, I wasn't going to, but it's on the ACT, SAT, and I was told by the department head, Mr. Felinsky, it's very important. So I'm here to try to help you be successful. And that's important for where you guys are going to demonstrate knowledge of this on the standardized tests and in this class. Okay, letter F. You only, obviously it's the same, but you have to decide which one works best for you. And on your own, I want you to try to do letter F. I'll be walking around if you're stuck, but try to get it.
Oh. They both go to the outside?
All right, guys, here is what I saw. I saw a lot of people using the factoring tree, which is great. I believe you had, if you could have seen earlier 4 and 4, but if you didn't see that, I saw a lot of people show 2, 2, which is great. There's 2 pairs of 2s. So you'd have 2 times 2 on the outside. You have 3 left on the inside. Then if you did the X's and the Y's, you'd have an X on the outside, an X on the inside, and a Y to the 5th on the outside. Your full correct answer should have been 4 absolute value of X, absolute value of Y to the 5th, square root of 3X. I saw a lot of people have absolute value of X, but we forgot about Y to the 5th. Let's think about that. If Y is a negative number, what's a negative to the 5th power going to become? Negative. So we have to make sure that that's positive too. If you are a little confused about the absolute values, there is a trick to help you remember. Here's the trick. If you have an even root and your answer is a variable with an odd exponent, you need absolute value. Let's write that just because it is helpful to know. I'll do it in this color. When taking even root and the answer variable has odd exponent, and then I'm going to put in big capital red letters, need absolute value. And I'll even show you the answer variable that's pointing to these, the 1 and the 5. Okay. If you didn't quite catch why do I need absolute value, I would memorize this because that's going to be the key takeaway for you to being successful with simplifying even radicals. All right, let's try another one. So on to letter G. Letter G, this one, why don't we go ahead and try this with some help? So turn to your partner. Let's do the oldest in the group. You share how you go about solving. If I give you big numbers like 144, well, probably not this one. Yeah. 12 times 12. So you actually found the perfect square. You found 2 12s, circle it, take one to the outside. What? Not on a lot of these. Why? Because it's part of like number sense. But on the SAT, half calculator, half non.
I forgot what I got.
This would, you guys should know 144 is 12 times 12. You know that. You know that. You know that. This particular one is the one I think you guys were talking about. It's not. Yeah, you guys will be fine. You guys are gonna be great. You're gonna be great. Yeah.
When you do 144,
yeah.
And then you like it sounds, you get just 3, you get 2 3s, and then you get.
If you went all the way down, you would get 2 2 3 2 2 3. So you have 2 pairs of 2s. So you're gonna take it to the outside. And you have a pair of 3s. So you're gonna take that to the outside.
Oh, so
what's 2 times 2 times 3? 12.
yeah, so it's 12 on the outside.
Yeah.
Yeah.
It is a perfect square. They're going the factoring route.
Oh.
You're going method 2, the perfect square route. They both will get you the answer. That's the goal.
No, we have absolute value for the X.
Yeah, you're so right. You do, because otherwise you're not following the definition. Can you sign out? Yeah. Oh, yeah. Okay. All right, guys, go ahead. Take a look when you're finished. Are you stuck, Joy? Did you try drawing them out? Like 1, 2, 3, 4, 5, 6, 7. So you need 2, right? Of the same. So if I take it out, I've got 1, take it to the outside. I've got another pair, take it to the outside. And I've got another pair, take it to the outside. And so that gives me X cubed. And if I drew out 9 Y's, there'd be 4 pairs. So I'd have Y to the 4th, but I'd have 1 left over. You just said it doesn't make any sense, but you explained it to me. You did it. You got it. It's going to take practice. It will take practice. All right, guys. Let's do letter H together, and then we'll talk about cubed roots, which I actually think you'll probably prefer. 128. I am a mix, I told you, between factoring tree or perfect square. If I know the perfect square that goes into it, I use that route. 128. Lainey, do you know the perfect square? Not typically. So what you do need to know is if it's an even number, then 2 divides into it evenly. It's 2 and 64. If you recognize 64, that's actually a perfect square. 8 times 8. I found a pair, so I'm not going to go any further. I take the pair to the outside, which means what's left under the radical for the 128? A 2. Now, if you're thinking about x to the 6th, I need to find 2 of the same factor before I can take it out. If you have 6 x's, how many pairs are going to be in 6 x's? 3. So I have x cubed on the outside. If I have 7 y's, 1, 2, 3, 4, 5, 6, 7, how many pairs are in 7 y's? 3. So I'm going to have y cubed, but how many are going to be left over? 1 inside. Yes, and I'm so happy that you guys are getting that. These both have odd exponents. You can put individual absolute value marks around each, or you could just pair them up together. But they have to be made positive to fit the bill. All right, let's talk about cubed roots. So with a square root, you're looking for a perfect square. To simplify a cubed root, you need to look for a perfect cube. Some of you know your perfect squares really well. You might want to memorize a few perfect cubes. 8 is a perfect cube, 27 is a perfect cube, 64 is a perfect cube, 125 is a perfect cube. Those are the ones I have memorized and they've helped me. But if you're not good at memorizing, you can always use the factoring tree. Let's take a look at the cubed root of 8. If I was factoring 8 down, it's 4 times 2, and 4 is recognized as 2 times 2. So if I'm factoring this through, I would have 2 times 2 times 2. What's the root of this one? What's that little, that's called the root. What's that number? 3. What do you think that means? You need how many? 3. I need 3 before I can take it outside the radical. Now I clump it together, and what's my answer? 2. So the cubed root of 8 is 2. Now let's also talk about negatives. What if I'm talking about the cubed root of -8? Square roots or even roots, you can't do that. It didn't fit the rule. But let's talk about cubed roots. What if I broke down -8 as -2 times -2 times -2? -2 is still a real number. Let me say that again. -2 is still a real number. You had to classify it on your quiz. Is -2 times -2 times -2 still -8? Yeah, still works. So what's my answer here? I have 3 of the same. So my answer would be -2. So here is the nice thing about odd roots. If you have an odd root, you can have a negative answer, which means you never need to worry about absolute value when working with variables. So if you see an odd root, just say, you know what, I don't even have to worry about absolute value. You can go ahead and just kind of mark that as just a nice little golden piece of information that'll help you as we move forward. Odd roots equal no need for absolute value. Let's do a few of these for practice. Letter A, the cubed root of 8. We did this one, but just to make sure you understand what we're doing, factor 8 down. 8 factors down into 4 times 2. 4 factors down into 2 times 2. Line up those pieces. And so if I'm looking at the cubed root of 8, I'm looking at the cubed root of 2 times 2 times 2. Again, that little root tells you how many you need before you can pull it out. So how many do we need? 3. I have 3, so I take it out as 1 clump. 2. Let's try another one. Letter B. 16. If you know your perfect cubes, you could break it apart, but I'm going to go the factoring route. What do you know goes into 16? Some people said 4 and 4. Some people said 8 and 2. We're both going to get to the same spot. What does 4 break down into? 2 and 2, and 4 breaks down into 2 and 2. So as I write this out, it's the cubed root of 2 times 2 times 2 times 2. How many of the same do I need before I can take it out? 3. So I see 3 of these. I'm going to cross it off, take it to the outside. And my answer will end up with 2 cubed roots of 2. Notice how I still kept that 3 in there because it's not a square root. If this was a square root, what's the square root of 16? 4. So it'd be a different answer. So keep that cubed root in there. Letter C. Let's do one more of these type. Actually, let's skip C. I want to make sure we can get to variables. Let's do D. What do you do if there's a number on the outside? Just multiply it with whatever you simplify. So let's take a look at 27. 9 and 3, good. And what does 9 break down into? 3 and 3. So if I rewrote this using the prime factors, that would be 3 times 3 times 3. How many do I need of the same before I can take it out? 3. So I'm going to take it to the outside. And then what is -4 times 3? -12. Let's do a variable one. Letter E. The cubed root of x to the 9th. Some of you know that x to the 9th is a perfect cube. If you don't know, you could just draw it out. How many x's are in x to the 9th? 9, 2, 3, 4, 5, 6, 7, 8, 9. How many do I need before I can take it out of the radical? 3, good. So I have 3 x's, cross it off, take it to the front. I have another 3 x's, cross it off, take it to the front. And I have another 3 x's, cross it off, take it to the front. Is there anything left under the radical? No, so what's our answer? X cubed. Do I need absolute value? No, because it's an odd root. It's odd, therefore no absolute value. That's only if it's an even root. Try letter F. See if you can get that one on your own. You should have x squared, y cubed, cubed root of y. Guys, homework is a worksheet. I gave you all the answers, which means if you want credit on it, what do you think I'm looking for?
Great.
Work for the worksheet. And then off-campus learning day is a quizzes assignment. It's already posted if you have study hall 6 or 7.
Thank you.
Really? You do. You do to keep it as a cubed root, not a square root. Yeah.
So there's a question like the cube root of 8, and I just know it's
2, just
2.
write it as 2.
I don't need to show any work right now.
No, but like if you do, so on the homework, like let's say it's the cubed root of 16. The only thing I'd want to see from you is that you know the cubed root of 8 and that separates to the cubed root of 2. So then it would be 2 cubed root of 2. So that's the only work I'm looking for. Okay.
And then like, on this test, we don't need show.
No, just choose one. Yes. Good question.
They are used absolutely that.
Yeah, they do. It's changing. We're making the curriculum harder and also more in line with what
Yeah.
should be, right? So we used to disregard it because we didn't think it was